one so late. Come on, this I thought it was done 5 minutes ago. Okay. To solve this problem, there was somebody has suggested the idea of, okay, so let's create one package manager to rule them all or unite them all. And so there were like 5 or 10 package managers to unite them all. And this was kind of becoming an annoyance. And often it was just easier to use something like Git subtree or Git submodule or a header on the library, which often worked if we just paste into our repo and it works. But this comes with a lot of other complications and just not the right thing. And we needed some means of resolving this mess. And there was eventually one thing that actually was shared by a lot of C++ projects, especially the more modern ones, and it was CMake. This is a nice thing that actually the projects eventually converge on one thing, and that is CMake. So I don't know the exact history, but I think somebody was just thinking, okay, that we need some package manager that will just work. And why don't we just slap it to CMake? Because everybody would actually have access to it. And for that reason, we actually got to the right. You stole my mouse. Well, first, let's just tell what is CMake. Although it isn't possible to just build a few C++ executables by using the GCC command or G++ command. It is generally, well, if we have multiple files, we need to include some stuff. Then it's generally better to have a CMake project. There are different approaches to this, but CMake is like pretty much the most common way of approaching this. This is how we set up this C++ project in CMake, or like this is absolutely the simplest CMake script. Right? No, not absolutely simplest, but kind of the basic stuff, something we can start with. So there is a certain minimum version required. I said if you set it to 330, I found that it works pretty well with this FetchContent somewhere. There are some subtle differences between different versions. And 330 was like resolve some complications that I had no idea what was going on there. So let's call the project dependent. We define it as a C++ language. We set it to require C++ 23 because we are people from the modern era. And we use this command add executable so that we just knows which binary should be built. This is the name of the project. We just attach the source file to it. And this is just some stuff that gets make installed to work with it on Linux distributions. But this part isn't necessary. I just found like, okay, we'll just mention this. So I suppose most of you are familiar with this. It happens way too often. So if you are using FetchContent, you are basically adding things into the CMake library. No, into the CMake script. This is like a fairly simple use case. I have created a header library for compressing and decompressing GZ archives. So I named it GZ. So I have it on Git, And it does have a CMake, but generate CMake script, but that's not useful because it's just for some testing and compilation and so on. You just need a header to use it. So in that case, you're not really having it as a dependency in the style of having one library, like one binary depend on another. We are basically just trying to have access to the header. So you just, if you do make available, if you do fetch content declare, you specify the Git repository that gets it. If when you get, then you use the make available command that downloads it. There is a reason why this first declared and then downloaded. I will come to it later. And we have this target include directories, which allow us to, well, it's not super. What is shining there? Something.
We can read the whole.
You can read it?
Yeah.
Okay, fine. So, so you can use the target include directories, which is a normal CMake command, and we just declare that you want this dependent to include this path. It looks like this because FetchContent will download everything that it downloads goes into something called FetchContent base dir, which is a folder created in your build folder.
And what if I declare FetchContent for s.r.o projects? Will they all be inside this base?
Yes, yes, because each of them has its name is downloaded into the name of the project dash src.
So you can rely on this name of the project that it will each project will go into name dash
Actually, I'm not certain if you can rely on it, but I will show later that there is a function that will tell you the name that will fill the actual folder where this thing is, where the entire library is placed into a variable that you can use it instead. But I wanted to avoid too many comments at this point.
Can it handle binaries?
Well, if you download the binary, well, yes, it is possible to do it also with binaries. There are multiple ways of downloading things, but with binaries, there is usually the problem that, okay, download the binary, but now you need to choose if it is actually a Linux binary or ARM library or Windows library and so on for each architecture, for each operating system and so on.
Yeah.
So, well, you would most likely want to just to download it and compile it from source. This way. Well, of course, it's not always possible. It looks ugly if you need to.
Yeah, I was just wondering whether FetchContent in general had some provision for
yes, it does.
downloading the already compiled artifacts. And then of course,
yes, there are multiple ways to define the source. It is just one of them, but in general, I was using only Git because usually it's enough.
yeah.
So yeah. Was there something like? Yeah, I just wanted to mention that this system argument means that when it compiles these headers, it doesn't report the warnings from inside these headers. I don't know why that causes it. Yeah, here's just the mention that if you name the build for the build, then the path will look like this. The project name is. Okay, so this is for something, a dependency that's slightly more complicated. YAML CPP is a library that's very modern. You can just download it from. It has a CMake install script that just does everything for you. No need to do anything weird, but you actually need to compile it. So again, we do FetchContent declare. just to showcase, you can specify the Git tag so that you can go for a specific version, because if you don't specify it, you'll just always pull the master or main. And if you, in that case, if there are some compatibility breaking changes, well, your project may start looking like a Python project. And Git shallow means that if you're downloading the repository from Git, you don't actually get the Git history and the other stuff. Then again, FetchContent make available, and when you have the project defined, you can mark use target link libraries to actually have SIG.json be marked as a dependency of this thing we call dependent. And in that case, well, FetchContent web make available will only pull it and run the CNAC on it. It will not actually start the compilation. If you go to targeting libraries and mark it as dependency, then when you start compiling, it says, okay, so I need to compile SIG.json so that I could compile dependent. So it compiles SIG.json and then it compiles dependent and links. Okay, so this will download one thing that it downloads it into SRC, it builds it into build, so it's a different folder. It automatically just splits this. So for this. Another thing that is pretty common is Boost. But still there's plenty of stuff that is useful. Even though some parts of Boost are no longer particularly useful because they were already superseded by stored libraries. But I've got some different project here. But the point is, if you download Boost, well, for some reasons you need to specify which libraries you actually want to include. Some of the Boost libraries are header only, such as Boost container. I found it super useful because there is a library called unordered flat map, which is like, well, pretty much just like unordered map, but much faster. The only downside is that modifying it invalidates iterators, which is usually quite inconsequential for the significant improvement in performance, like threefold. So yeah, that's one thing that's super useful there. So other libraries like Boost S.r.o or Boost Compat have actually some source files, not just includes. So in that case, you need to do target link library, include and link them this way, and you can do it for multiple other Boost components. You only need to check if they are header only or not, because those that are header only are need to be marked as includes only. The reason why this is slightly more complicated is that Boost is quite a large module and it's quite large and composed from like 50 modules. So you basically usually don't want them all. In case you ask what is Boost Compat for, it contains implementations of some library functions from higher versions of C++. So if you miss something from C++ 26, you can use Boost Compat. It has some utilities from there. Of course, not the part that require language support like reflection, but there are still a few goodies. Now the remark why do we even need to do this make available function? The reason is that if we have multiple dependencies, make available will actually make connections between them. And like find which one depends on which one. And in that case, we don't want to just explicitly define an order. We just do fetch content make available and put all the dependencies we have there, and it finds the order of dependency between the dependencies.
What if one of the projects that we are fetching with fetch content also uses fetch content inside its own build system?
Well, if we are already fetching it will use ours, or there is a tag that will make it called override. I will show it later. Something like override find package, so that if this sub project finds out that okay, but we already have this because make available overrides it, so it already finds it as available and doesn't download it. In case it's not present, then of course it just does the same fetch content as the project on top of it. Just inside its build folder, it creates a depth folder and creates a folder for this dependency.
Yeah, that's the actual dependency management, right? Because without that, that's just dependency collection.
Yes.
But if you once you start managing the versions and the number of them that you always use only one, that's
Yeah, so like that's the reason why this command make available exists. That's basically it actually resolve this internal dependencies between each other. Another thing that is there. Oh, no, I don't remember. Never mind. I guess I'll come to that. Yeah, actually, this recursive fetch content can imply that if you don't override the find package, it may like implicitly solve some problems that you may come across, like different versions of the dependency, that one depends on one version, the other one depends on another version, but one of them has it inside its own build, and as long as it doesn't expose it, you can just have a different version elsewhere and it doesn't clash. But, well, this would be fast, but if you actually try this in practice, you'll find that not everything works the way it was expected, because fetch content is mainly useful for using stuff that's not exactly there is no curated list of packages anywhere, and you are just using it to get pretty much any libraries. You are not looking at a specific package manager that has like, okay, these packages are like, common. Just, yeah, you have some libraries package for common, you just download them and it works. But the problem is if your library isn't available for common, so like, this sucks. Which fetch content has the advantage that it kind of works for stuff that's not specifically prepared for anything. So like I will spend pretty much the rest of this talk just explaining how to improvise if it doesn't work perfectly. So like this can be legacy projects because that just happens. They haven't been updated for long. Somebody may have been improvising and like thinking a little bit out of the box and then creating lots of, and then just making things work in ways that just don't make the standard approaches viable. So let's delve into this. So one thing that can happen is that there is a CMake script, everything will be fine, but there are some deprecated functions. And CMake has gone way up, and if you look at and if we try to just open it normally with CMake, we see that okay, but it tells us this function is deprecated and you shouldn't use it. Stop. Okay, but actually this is not my project. I want to get it working. So what you can do is that you can use set CMake policy version with the set property command. Or in this specific case, if you want to use C-array, it's 3.5. If you set it to 3.5, it's thought, okay, we are going in compatibility mode. So we are not going to warn that these functions are deprecated. So I don't know why CMake deprecates things so quickly, much faster than C++ does. So this is how we solve this one complication. Then another thing that you may need to set is that there are some configure flags that you need to actually set. If you are building it manually, you would usually run CMake. Then there is this program called CMake GUI. You open it, it shows you the list of variables that can be assigned from in the build, and you just set them the way you want so that you adjust the build. One library that does this is fmtlib, which is fairly common library. And for example, you can set it to like set header only and disable tests and disable installing, because in practice you just want to use it as a header only, so why to install it? You need to set this variable before calling it make available.
They need to be cache variables, or can we just set them as normal variables and do it?
Well, I'm not sure actually they need to be cached.
So then they would show up in the CMake GUI for my project. Maybe I don't want this.
Oh, well, you don't want them to show for your project, definitely. I'm not sure whether they need to be cached, honestly. Maybe that's what the libraries expect when they are being like running the CMake for the first time. Because one thing is that if you set these variables, they remain set in they are like global variables. If you go inside the target CMake, they are still set, and you can use them to configure some things about the way it compiles, which is often quite important. Okay. So I got a pretty nasty surprise when something had dependency on protocol buffers, and told me first, git submodule update init recursive called autogen, called configure, and then you can just go make. No CMake for that whatsoever. This isn't well. Here it was starting to get complicated because, well, this is not the standard way of doing things.
It used to be.
Well, yeah, auto tools.
CMake.
Yeah, well, auto tools. I mean, they were teaching me that at school it was a nightmare.
Yeah, it was.
Good luck with that on Windows.
Yeah, that's another thing. Wow. So, one thing that you can do with, well, if you are on Windows, well, CMake won't help you. If you are, but sometimes there are scripts that there is a batch file for Windows as well as some automake or something like that command for Linux, so that you use one of them so that it prepares the make file. Like that's one step further in the, it really hurts we didn't create CMake. here. So, yeah. So in practice, if you get into something like this, usually the approach is to use the execute process command. Typically, it will look like this. You write a command, use the working directory. In one case, I screwed up and wrote the entire path here, and just was looking for protobuf source there / the same path again. So like, careful, this is not the top level path. Yeah, so well, we just specify the directory, and if there are some command line flags, you just put them before the quotation lines, like just like it was a page command. You are setting 3 variables with this. If you don't specify them, just it should work. It just won't set anything, and you are difficulty debugging it. Result is a number, but given that Unix has some specific numbers that belong to certain specific errors. So if you do bootstrap, so well, you know this, if you do some Linux programming, that if you just get an error code, you get this error no, and you just use this function called error, which just prints out whatever was there. If you use the result will tell you what was the actual error that, what was the basic return value from that script. If the output tells you whatever it dumped into the standard output, and error is whatever it dumped into the standard error output. In practice, it makes more sense to print result than error, because of sometimes you say like found not found, and then it doesn't give you any error, any output, just the result.
Why don't you use the external project instead of
I will come to that, but you can totally use external project too, but sometimes this execute process is useful too. It depends on the situation. In this case, yeah, the problem, well, it would have to be a little improvised, because you have 2 commands that you need to run.
we need to what?
Well, there are 2 commands that you need to run to actually get to the make file.
Yeah.
Well, you could probably change them inside the command in
Usually
external content add.
Build protobuf, and that one I call. But the external project has the benefit of not rebuilding everything. If I just, for instance, reconfigure.
Yeah, I mean, I wanted this to showcase. I will come to external project as well. So this is if you need to run some comments before fixing it. I mean, there are some projects that actually do have, well, this can get even more annoying, that there is some kind of configure command that you need to run. And then you need to run the cmake, because there is some magic that needs to be called to actually create the cmake script itself, because they want to have as many levels of code generation as possible. So in that case, you need to actually use the cmake command as an execute process, because they designed it that way, which is there is actually some kind of variable that I think it's called cmake command, which is a like global variable always said that you can use to actually avoid like this writing cmake like explicitly the name of the executable. Yeah, this is the part that we have already been talking about. Unsatisfied transitive dependence. Yeah. Well, yeah, we talked that transitive dependencies are general kind of, well, that are generally solved with this. We can use the make available to actually provide them. Unfortunately, well, one thing that I didn't mention when I was answering your question is that sometimes some libraries will get some pretty weird ways to look for libraries for their dependencies. And they just go for the CMake prefix path and they search for them there. And if they do this, we cannot do override find package because they have their own find package that isn't even called find package. So in that case, what you need to do is to actually add your binary directory into the CMake prefix path. Because CMake's prefix path are just the places where you are looking for things that were for the dependencies that have theirs, like find something scripts, which is where you find the system libraries. Unfortunately, the libraries you are building with your own project are not system libraries. So you need to add your path there. So if you, for example, do this for this binary there, this is the actual build directory where it is built. And if you use CMake prefix path, yeah, this way you will just add also this one place where you build it to the list of places where it looks for it. So this can help it find it. Yeah, this, well, the text said this is the worst way a CMake script author can complicate the usage of FetchContent, but I found the worst way yesterday. Okay, so the problem is that sometimes they just write their own script that actually looks for the executables that are supposed to be there, not executables. I mean libraries. You just want to build some static library. So there's something .a or .lib, and already CMake is looking specifically for this library that is already built. So, but there is this problem that you are still compiling your code. You know, you are just configuring your code, but it expects that things that are supposed to come out of the compile step are already there. So this is really annoying. And basically what you need to do, what I found is that, yes, you can pull it with FetchContent, it configures, but then you have to actually call make explicitly on it. There is a function called processor count that will get you the list of CPUs you have so that you could tell it how many parallel jobs you want to use. And that way you actually do the make, you actually build it in the configuration step of your own project. Then you can do like make install to place it in a specific folder. And once it is in that folder, you can just set the variables where it is supposed to look for it so that it finds it there. Which is quite a nasty workaround. What can you do if they do something like this? What I have found is what I have found is to be even worse is that if it uses some kind of tool that just isn't available on your system, like well, auto tools can be an issue if you usually have it installed on Linux, but I think it may use some kind of different builds like Bazel or Mason. Mason? I don't know what's the correct pronunciation, but if it just uses some different build system, some kind of command like so I'm gonna install it on my system now, or again we can get it with FetchContent, but in that case you actually you can build the actual build system. And then again, using the same steps, you build it in the configuration phase. And then you actually have the executable somewhere that you, it's in some folder that you have built. And then you can finally use this thing you have just built to actually configure this dependent project. But if it gets to this, it's not very important. This is just an example how that this. Yeah, this is an example with the CMake command that if you do this, that you can explicitly call CMake or something outside of the main route. We can just add more arguments. Yeah, and yeah, this is the part that you already mentioned, alternative for completely unsuitable projects. So if something is just seems too unfit for fetch content, the approach is often to use the older alternative external project add. It's not a true true dependency manager, but it can do the job if it really needs to. It is similar to FetchContent, but there isn't any there isn't this make available stack. You basically similarly just specify the Git repository, the Git tag, or some other source. You specify where it actually goes. It would be convenient to just reuse the FetchContent based view because why to create a mess there. You can do configure commands, build command, install command, you can just put anything you want there, which will be obviously useful to use the CMake command because you may not know if it is called CMake or if you are using like CMake dash some version or CMake.exe or something like that. And yeah, this specific library has a cooking.sh library that script that actually downloads and builds all dependencies, and then crashes because one of them depends on a version of the library that uses functions that have been deprecated from CMake, and then they have been removed. Their support have already been removed. So if you have a new version of CMake, this thing just won't build. So yeah, actually there is a master version that will solve this, and this cooking command can is a possibility to specify that I don't want to build some specific dependencies, and therefore it will not build them, and I might be able to actually reuse them from my own setup. And because the latest release has some really old CMake script, the newest master uses a newer one. So in this case, I can solve it by actually getting it with FetchContent, everything over there, and then I do external project to just download the stuff that is inconvenient for other reasons. So isn't like the main, as I say, the main purpose of FetchContent isn't to be a perfect package manager, but to be something that you can use if you are just trying to have a script that actually prepares all the dependencies and they are not written to abide by the rules of any package manager or anything. So there will be always a little bit of, there will always be a bit of improvisation, but the more modern the project is, the more likely it is to work without any issues. And, yes, that's all. Any questions?
Do I have to choose if FetchContent or package manager, or can someone combine? One package that isn't in one of my package manager and isn't compatible. Can I use FetchContent for this? Or is it
Well, you can use FetchContent pretty much for anything. If Well, I think that given that FetchContent is already in a CMake script and pretty much any, even those things that you get through some package manager will actually end up being built eventually with the package manager. So I suppose that if you just that it should work together if you maybe use some command or build the package manager first by FetchContent. Well, you will not be able to do everything with FetchContent because you need to have it built already at the configuration stage. But as I showed, you can get that one working too. So yeah, it should be compatible with others, but I didn't try it because you can just get whatever you want from Git. And if somebody put enough effort to put something into a package manager, it's quite likely he will also have a nice CMake command that will play well with other CMake code.
Can you use different protocols than Git?
Yes. You can just, I have seen it. I think you can just use it to simply download a file from URL and pack it. I've seen, there are multiple things I have seen, but I think the two I have seen was just Git and just explicitly downloading some stuff from SourceForge or something.
So if I have some SVN or some other,
I suppose SVN shouldn't be an issue.
and you cannot plug a new protocol into.
No, when I was looking at it, there was a lot of things that were supported, but there was just an exhaustive list of things that were supported.
Is it correct that FetchContent is somewhat alternative to Git submodules, but not to full-blown package manager? There is no pre-built binaries. It's just getting the sources and calling that subdirectory, basically.
Well, I think that they are kind of competing. If you are using FetchContent, you can use those Git submodules argument to the FetchContent declaration to make it fetch the Git for the Git repository together with all of its submodules.
No, my point is that I could use either Git submodule in my own project. I could use Git submodule and then call that subdirectory in CMake, or I can do FetchContent, and it's the same basically. Just
yeah, it will be similar. Yeah, it will be similar. But
can you ship with Git submodules? Can you so easily ship your Git submodule configuration to?
No, I mean, I'm not. Yeah, I agree that the Git submodules are not like have many problems. Let's say.
Well,
I'm just trying to compare FetchContent to something.
Well, the advantage of FetchContent is that it's done in the build step.
Yeah.
So it's not actually part of the repository at all. But, well, actually Git solves many of these problems with submodules, with subtrees. But it has the new problem. You almost don't realize that you are in a subtree. But
the advantage that I see here is that actually you can use FetchContent in your CMake, and you can give that to anyone. You can have that in your Git repo, they can download it, and the FetchContent that you have encoded there will also resolve the dependencies to them. Without needing to set up manually anything on the.
Well, one advantage I can think about is that if you have duplicate dependencies, because some modules would just keep creating more and more sub-modules that will just start creating redundant copies of things, while FetchContent, if you just see that, okay, this one is duplicated, you just put it as a dependency directly and it will find it.
Yeah.
I'm not sure if actually the internal FetchContent comments will be synchronized this way. Maybe they will, I'm certain, but there will be probably problems with the versions. More questions? Because actually I was preparing for a different